Hi everyone, this is Mikey N6IL, and today I'm going to do a video for you about the FDOS operating system. I'm not going to go do a complete overview of the operating system. Instead, I will refer you to a video by DRAMP or Mike Douglas for a more general overview. What I'm going to go over today is going to be the programming experience on this operating system. They did provide an editor assembler, so that means that you can write programs for it, and we're just going to take that for a little spin. A quick review: this operating system was released with the MF68 disk system, and it was just a way to be able to use the system. It's a very, very simple operating system, as Mike points out in his video. So the way I'm going to be demonstrating this for you is I'm going to be using the MAME emulator. Now, the MAME emulator does actually support the SWTPC 6800 computer, but it did not have support for FDOS. FDOS, I think, was recently restored or found by some people who were doing preservation, and Mike Douglas took that and actually got it to work on real hardware. So this is the change I submitted myself to MAME to actually add the disk format so that you can take Mike Douglas's disk image and just attach it straight into MAME, and off it goes. It's pretty simple. It's just 35 tracks, 10 sectors per track, 256 bytes. There's nothing really that fancy about this disk image. Okay, so this is the main part. We'll get back to that in a moment. The next thing that we need to do is we actually need to obtain the operating system. So this is Mike Douglas's website, dramp.com, and he has a bunch of information for a whole bunch of other systems. Again, today we're talking about the SWTPC 6800 computer. And he has an excellent download section. So on the top of the screen, you just click Downloads. And we are looking today for SWTPC, which is here. And then we're looking at the software. And he has a directory called FDOS. In this directory, there's a few things here. We want to look at the disk images, obviously, because we want to need to attach that into MAME. So it has a little document that describes what's actually in the disk images, and the important thing that we need to pay attention to is this right here. The version that Mike Douglas worked on to work on real hardware was this disk called FDOS MPS.disk. MPS is the serial card for the machine. And that serial card is exactly what MAME has in it already. So we go back to the list of downloads. We will just download this one right here, FDOS MPS, and we can attach that straight into MAME, which we will go to now. So you guys know that I am a terminal guy, so that's normally how I launch MAME. So I have a directory here. I have the documents that I've been showing you guys. I also have the disk image right here. And I have another disk, which I'm going to use for a working disk to save the example source code and whatnot. Okay, so we're going to run MAME. This is one that I compiled myself, but you can download a binary when that's available. It should be very, very soon. MAME window SWTPC. That's pretty much all you need to bring this up. Now you can also add disk images on the command line, or you can select them. Either one, it doesn't really matter that much. To save a bunch of flailing around, I'm just going to put it right here. FDOS mps.disk in disk 1, and disk 2, FDOS work2.disk. Okay, when I hit enter here, MAME is going to start up. And there we are. So while we're here in MAME, let's check a couple of things. First, a very important setting. This setting right here, SWTBug disk boot patch. This is very important. The default setting for this is yes. In order for FDOS to boot, you must set this to no. It will not boot if you have it set to yes. I still do not completely understand why the default for this is yes. I'm still working on trying to determine that. But make sure that you have this SWTBug disk boot patch set to no. Okay. Then for review, we're going to double check our disk images. I have FDOS mps.disk, which is the boot disk that I need. And I have FDOS work2 disk, which is the one we're going to use for saving our source code. All right. So with all of that in order, I think we just type D to boot the system. And there we are. Now we're in FDOS. Of course, we don't have directory, but we have cat, and there's a command called files. So this is, of course, on the boot disk. I want to start with a fresh disk for my working disk. I'm going to go ahead and initialize that right now, which will just take a couple of seconds. You say init 1. Are you sure? Yes. And it's not the wonderful sounds, but this is the same, all caps. And it's just official. All right. So with that disk initialized, we can take a look at it. It just has the DOS file on it. It has nothing else. So if you saw on the boot disk, we have a program called Course, which is the Co-Resident Editor and Assembler by SWTPC. So we're going to go ahead and launch that. If I can type Course. And there we are. So let's talk about Course a little bit. Course is the Co-Resident Editor and Assembler, as we talked about. And they make it sound so good here. The Co-Res Editor Assembler package allows the user to considerably reduce the amount of time involved in writing programs. The editor allows the composition and modification of assembler-level programs written in mnemonics to be stored in memory. The assembler changes this source program into hexadecimal machine code. Yeah, that's what an editor and assembler does. Okay. So we're just going to go through the instructions a little bit here. Carriage return completes a line. They say that control X exits the has control X to delete the input, blah 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 blah. We can insert lines. Most importantly, we want to briefly go through the commands that they have, which they start listing here. List shows us the listing. Change the order of the lines. save a file, load a file, searching, new to clear the memory, automatic line numbering, and assemble. Some error messages, and they talk about the assembler. Mike showed this in his video, that with this assembler you have to run it's multiple passes, and you have to run each pass separately. So you have the first pass, which generates a symbol table, and the second pass generates a listing and also writes the object file to disk. Now they say Control X edits the assembler, but it does not. Okay, I will spare you guys the rest of the manual, but now we're ready to actually start entering a sample program, which is right here in the course manual. So that's right here. Okay. Now it's time for some typing practice. You guys ready? I've typed this a number of times already, so I think I should be able to get it correct. Yeah, let's go. We'll use automatic line numbering. All right, so now we start the program. Start. Pretty straightforward. I just made a mistake. We'll fix that in a minute. Okay, and then now we're at the end. Be sure the command is in the right column. We have to type a space here, end. Okay. And to get out of here, the only way that I know is Control C. So we already know we made a mistake on line 100, so let's go ahead and fix that. Come on. All right, I think we finally have everything typed in correctly here after a couple mistakes. Yeah, that looks good. Okay, so before I want to go on, I'm going to save this to my working disk. Save to disk 1, demo 1, and I put the /A on the end so that I know that it's the assembly file. It's a little tricky to tell. They don't have extensions. They have file types. I could tell by the file type, but this is easier. Okay, now we go into the assembler. And as we said before, we do the first pass. It seems like there is some kind of error. Okay. Let's see if we can figure out what went wrong. Oh, yeah, that's not right. Line 130 is also wrong. So label message FDB. I think I was talking. Okay. That looks better. We can save on top of it. It'll just override it. As long as the files are the same size or smaller, this should work correctly. If not, the worst that'll happen is we'll just get a couple of typos back and have to fix them again. Okay, let's try the assembler again. And this time it's clean. If we do pass 2 with the listing, this is what our listing looks like. We can review this. If we go down to the next page, we can actually make sure that the listing looks correct. So starting at 4000 instead of 0, CE 4009, BD, yep, looks good. Yeah. Notice that line 140, which has the FCC on it, it only prints the first character here. It doesn't print the entire message, and then it has 04, the end of the message, and the org. Okay, so let's try to write this to the disk and see what happens. We type 2T. It will ask us where to save it. Save this to demo 1. And we get some kind of an error message. File full. Rename. Okay, I don't know exactly what that means. I think it wrote something to the disk. We can go ahead and check and see what's up with that. So here's what we have on disk 1. We have our source code and we have demo 1. We can just try loading it and see what happens. Okay, we'll load it into memory, and we can actually check what we have in memory and see if that looks like our program. It looks like it. Look, that definitely looks like our program. Yeah. And this looks like the message. But that's all we got, apparently. The rest of it is just 5. So I think if we run this, we're going to be seeing a lot of U's on the screen. We can try it. It's not going to do what we expect. Like I said, that is not the complete program. So a couple of things are going wrong. All right. Do a reset. Boot back into DOS. Rerun course. Okay. So let's study this for a minute. Oh, I need to load the program back in. Okay, so the error message was memory file full. So I think what's going on is down at line 170, where we have the address for the G command to run at. We know where we need to go. We know the org is at 4000, line 90. So we can just get rid of those. And then, yeah, let's just get rid of those. So let's just say 160. We'll make that the end. And then we delete 170, 180, and 190. So that's it. We just chopped off the end of the program. Let's save this as demo 2. Save early, save often, they say, right? So let's try to assemble this. First pass is good. Our listing looks good. Try to save it to disk. See if I'll actually save it correctly. Okay, should be done, but actually it's not. It got stuck. I can't type anything. Okay, reset time. And boot back into DOS, so we'll see what we got this time. It wrote the file, but I'm starting to notice something here. If you see not demo1/a, which is the source code, demo1, you notice if I flip back over to here, so we can see the program listing, along with the FIOS listing here, I think we see a problem. If you look at the listing, you see that it starts at 0 and it goes all the way up to basically 20. In our case, there'll be 4,000 to 4,020. But if you look at Demo 1 and Demo 2, they start at 4,000 and they only go up to 4,000C. A little bit short. This sort of agrees with what we saw when we loaded Demo 1. I think if we try to load Demo 2 into memory, well, it says not found. I think there were some extra spaces or something there. So if we exit out of this and look at memory again, I have to type dot. Program, end program. Here's the control characters. Here's the first 2 letters of the message. And then basically we have junk again. If we ran this, it would be exactly like the last time. So clearly there's still something going on with the assembler. It seems like there's some kind of assembler bug that we're hitting. So let's boot back into FDOS, run cores. Load our source code back in. Run demo 2. Right, so this is the second time. So it seems like the problem is for the FCC on line 140, it only has 2 characters. Either it's getting lost, it's missing the N, something is wrong. I think we might be able to trick this thing into working. If we add line 155, and I'm going to make a label called end, and the instruction is no op. So that's going to look like this. I just added it right before the end. Add an instruction in there. Let's save this. All right. Let's assemble this. First pass is good. Yeah, see the length of this is 4,000 to 4021. So this is important. We should see that in the output when it gets written to disk. So let's go ahead and do that. I think we're on demo 3. See if this completes successfully. And it does. Okay, good. So let's take a look at what we got on disk. Yeah, we said 4021. It got 1 extra byte, 4022. That's not going to make any difference. So I think now if we load demo 3, take a look at that. 4,000. We're looking at this program again. This is the end of the program at 8. Just 9 is starting the message. The control characters. Now it looks like we have the entire message here, which should include, this is a space, TEST. We should have the 04 for the end of message. Okay, it's actually here now. And then the 2 extra bytes, which this is our no-op that we put in, and that's just an extra byte. It doesn't make any difference. Just some other assembler bug. And then after this we have UUUU, but we're not going to see this anymore. If we actually run this program, now importantly we have the 04 at address 4020, which is the end of message. So when we actually run this, Yeah, it didn't clear the screen, move the cursor, whatever, but that doesn't matter. Our terminal ignored those. That's fine. It printed the message correctly. It didn't go off into la la land typing you. It actually worked. So we successfully used Course to assemble a little program, and we actually did a little debugging, and we got it working. So yeah, this is pretty much what the FDOS programming experience is like. It's pretty primitive. As Mike said, it's basically like having an advanced, faster, bigger version of a cassette. But at least we can save things, load them back in, try it out, save it, load it. We actually have the tools that we need to write and debug the program, figure out what happened, etc. So yeah, this is the FDOS programming experience running inside the MAME emulator. And that's what I wanted to demonstrate to you today. So I hope you enjoyed this. Bye everyone.